part of section 2.2, and so we're just going to look at, once again, how to find the derivative in given circumstances. And so if you look up here on the board, okay, you're going to notice we have y equals 5 divided by 2x quantity cubed. First of all, if you remember, I said you can't find the derivative if a variable is in the denominator, so you need to somehow simplify that. So what we're going to do first is we're going to distribute that cubed power. Okay, so we distribute it to both the 2 and the x, and what do I get? 8x cubed. Now, if you remember how I started, I said that we can't find the derivative if we have a variable in the denominator. So how do I write that so it's not in the denominator? That's what 2 times 2 times 2 is? How do I get it so it's not in the denominator? X to the negative third. Very good. So then now, let's go ahead, and if you remember from yesterday, I bring the negative 3, where? Around front. Very good. And so what's my new fraction? Negative 15 over 8. Here's the easy way, guys. All you have to do is take the negative 3 times the 5 and leave the 8 alone. Okay? Negative 3 times 5. Now, one of the things we need to do is subtract 1, and so this is what I always do. When I subtract 1, I just imagine I've got negative 3 and negative 1, and you add them together. Negative 3 and negative 1 is negative 4. But remember, I don't let you answer negatives in the numerator, so we actually need to finish our answer. It'll be negative 15 over 8x to the 4th. So when you have a quantity, you've got to get rid of that power first. So another scenario you might run into. What happens with this one?
Yeah, how do you know ones that either times it or just so 7 times x.
Remember, you cannot find the derivative if the variable is in the denominator. So you've got to get it out of the denominator. So really, this is the problem. Okay, so what do you get? You're right. 14 thirds x, very good, because you bring the 2 around front and then you subtract 1 from the 2. Nice job. Okay, so that one actually turned out to be real slick. But it's one of those things you can't find the derivative if the variable's in the denominator. So we're going to talk about 2 derivatives. Now eventually, I'm going to give you a reference sheet that has all the derivatives you need to know. Okay, and it will list those. It will also list integrals, things like that. We're waiting for the laminator to get fixed. Once it does, I will get that done for you. But for now, you need to remember that the derivative of sine is cosine. And the derivative of cosine is negative sine. So you need to file those away to memory. The derivative of sine is cosine. The derivative of cosine is negative sine.
And so this is just 2 cosine?
So now the nice thing about these is there's really no operations that need to be done. If I want to find the derivative here, I'm just going to take 2 times whatever the derivative of sine is. And what's the derivative of sine? Cosine. So your answer here is just 2 times the cosine of x. There's no hidden trick. That's the derivative, and you're done. That's the nice thing about the trig functions, because they already give you what the derivative is. So let's look at this one. Y equals x plus cosine x. So now if you remember from yesterday, the very last thing we looked at is what happens when you have multiple terms. What happens when you have multiple terms? What do? Derivative, yeah, derivative of each term. And so what's the derivative of x going to be? 1. Okay. What's the derivative of cosine? Negative sine of x. So there you go. That derivative is 1 minus sine x, or 1 plus negative sine x, and that's it. Okay, sine x over 2. Now, that 2 is deceiving. This is all the 2 is. It's just a 1/2 disguised. That's all it is. Okay? And so it's one of those things you're going to have to look and you're going to have to think, okay, is there a way I can rewrite this that makes it a little bit easier to view? And so what would my derivative be in this problem then? There you go. That's it. Okay? All right, now the very last one we're going to look at. This is one that it doesn't matter how many times we look at it, there's always going to be somebody that forgets what to do. Now, if you remember, what did I say about variables if we're finding derivatives? They can't be where? In the denominator. So I've got to somehow figure out a way to get rid of that x in the denominator. So the best way to do that, and I'm going to write this out the long way, dividing each term by x. You can't just divide one, you've got to divide all 3. So by dividing the first one, I get 2x. Okay? Dividing the second one, what do you get? And the last one I'm going to write this as x to the -1. Now notice, this is still the original function. This is still the original function. You have not found the derivative. So now what we need to do is we need to actually find the derivative. Okay? What's the derivative of 2x? What's the derivative of -3? 0. And then what's the derivative here? -1, x to what power? -2. So my final answer will just be 2 minus 1 over x squared. Now there is another way that I've done this in the past, and it might help you remember. Okay, we kind of call this the bunny ears, because really what you're doing is you're doing that. And this one, bunny, actually has 3 ears. And then you're doing that. Okay, so it usually works really well when you have 2. It looks like bunny ears. Okay, when you have 3 or 4, you have to extend it out. But that's another way that you can view what we did. You just need to divide each individual term by whatever the denominator is. Okay. Questions? Remember your assignment from yesterday? You have the rest of the time to work.